Chapter 19, Electric Field Problems. This is our last main chapter that we'll get to in the book. First, let's start with electric field strength. Let me tell you what the formulas are, then we'll work through a worksheet. Electric field strength, or E, there's two formulas. Remember, that's just how strong the field is at any particular area, so that's why it's force over charge. Remember, force is measured in newtons, charge is measured in coulombs, so that's its unit. The other formula, I'll just put that in parentheses, same thing for electric field strength, but it's KQ over R squared, where K is the constant, 8.99 times 10 to the 9th. Q is the charge. Radius is the distance. It's always measured in meters, so still same unit. Electric potential is measured in volts. The first formula we'll use, a lot of times you'll see V, so we'll say V equals U over Q. U, electric potential energy, is joules, charge, coulombs, and actually that is a derived unit. A joule over a coulomb is 1 volt. So that's why electric potential is measured in volts. The other formula for it is KQ over just R. Then you have potential difference. Now on this test, I will provide the formulas themselves, but I will not describe and give units and anything, but it will literally be just the formulas. But potential difference is change in energy over charge, or just subtract the two electric potentials. So it's according to what they give you, and since you're just subtracting, it of course is still in volts, same unit. Capacitance is measured in farads, remember, after Michael Faraday. Two formulas for it: charge over potential difference, or, and this formula is the one we use more often, epsilon, which is the dielectric constant, what value it is. We personally work with in a vacuum or air, so it's right at 1. A is the area of the plates, and then it's 4 pi K D. And so that's the formulas we're going to be using. So now, let's get busy. On the first one, here's our worksheet. Now, just like normal, even though I know there's 1, 2, 3, 4, 5, technically 4 different things to each, you can easily figure out what to do. Because this one, we've got charge. We've got electric potential energy, and we want electric potential. So out of those formulas, we've got electric potential, we've got energy, we've got charge. So electric potential is going to equal U over Q. So electric potential, what you're looking for, that's a terrible U. Potential energy, 8.5 times 10 negative 6 joules over 0.00253 coulombs. Work your magic, do your division, and it should be 0.0034. And electric potential measured in volts. Then, let's keep trucking. Large, we've got a force this time. Charge, what is the electric field strength? Well, electric field strength has two different ones, force and charge, and constant, charge, and distance. This one says nothing about distance, so it's got to be this one. So electric field strength equals force, 6.7 times 10 negative 3, over charge, 7.1 times 10 negative 6. Do your division, 943.66. And remember, there is no unit for electric field strength as far as a derived unit, so just Newton over coulombs. All right, then we've got a capacitor, capacitance, so that narrows us down to 2. They give us the area, vacuum, so epsilon is 1, 0.019189 meters apart, so you know it's this formula, epsilon A over 4 pi k d. So epsilon, of course, 1. Area they give you, 4.3 times 10 negative 4. 4 pi. Constant, remember, 8.99 times 10 to the 9th. And the distance between the plates, 0.0189. This divided by all 4 of those multiplied. I just used 3.14 for pi. You could use the pi button. Either way, you should get around 2 times 10 to the negative 13. And capacitance measured in farads. And you can see this chapter, it's pretty straightforward as long as you have an idea of your units and look for different things. This one we've got charge. What is the electric potential? We've got distance. Then they want the electric potential 0.16 meters away. And then they want potential difference. So if they want the electric potential here, the electric potential here, and then potential difference, guess what we're going to do? We're going to find the first two and you got it, subtract. Now electric potential, remember, equals KQ over R. So we're going to have 8.99 times 10 to the 9th. Charge, 1.8 times 10 negative 5th over distance, 0.0056. Plug it all in. You should get 2.9 times 10 to the 7th. Now the only difference for B is the difference, or the distance rather, is 0.16. So constant's the same, charge is the same. You're just going to divide by this instead of that. It's just slight difference. It's maybe about like 1 times 10 to the 6th. And you can notice I rounded on those. So now C, subtract the 2. And it should be around 2.8 times 10 to the 7th. Okay, we got a charge, distance away, electric field strength. So KQ over R squared. So K Q, 2.5 times 10 negative 4 over radius squared. Don't forget, multiply those two divided by this squared. I would probably use parentheses. Just be careful. And you should get 2.6 times 10. Oh, forgot my units. I'm sorry. I'll go back and do them. 16 electric field strength, Newton over Coulomb. This one, electric potential, so volts, volts, volts. Sorry about that. Then let's see what we got. Moving on. Yeah, capacitance is charge, what is the potential difference? Well, remember you've got two formulas for capacitance, charge over potential difference, or the one we did a minute ago, epsilon A 4 pi kd. Well, of course, since this one gives you charge and potential difference, capacitance equals charge over potential difference. So basically, remember, x is underneath, just like with trig, you're going to divide, so it's going to be kind of like you swap those. So 4 times 10 negative 12 divided by that, and it should be, I believe, about 75.5 potential difference measured in volts. Oh wait, that should be 14, I'm sorry. There we go. 75.5 volts. Alright, two more. Rectangular capacitor, length and width. Vacuum, dielectric's 1, and as soon as they mention the dielectric, and they're talking about capacitor, what's the capacitance? Well, you know what formula they want. Epsilon area, 0.3 times 1.5, 0.45 over 4 pi K, and D. Well, the first one, they want the distance of 0.005. So you're going to plug in the formula, work your magic, and you should get about 7.9 times 10 to the negative 10 farads. Well, B, they wanted minimum separation. So that's going to be the exact same formula, literally, except the distance apart, 0.00017 meters. Work it all out. You should get 2.3 times 10 negative 8 farads. And last, capacitance has charge of, potential difference, wanting its capacitance. So literally just charge 2.8 times 10 negative 11 over potential difference. Divide them out. 3.8 times 10 to the negative 13 farads. So you can see the formulas the formulas are kind of straightforward if you know them. And remember, here is what I will literally give you on the test. Force over Q, or R squared. Electric fields, or electric potential rather, energy over Q, or KQ over R. Potential difference, change in energy over Q, and it's obvious you just subtract, so I'm not going to tell you that. Capacitance is charge over potential difference, or epsilon area 4 pi k d. So something like that is what I would provide for you. No units, no description of what the variables are, but I would provide that for you. So, hope this was of help. As normal, any questions, let me know. Have a great day.